Okay, let's give you guys some practice now. So I've got a triangle with these three vertices. So this one here would be -1, 1 across, and then 2 up. 1, 2. So it'd be around here. For this one here, it would be 1, and then -1, and then 0 up. So it would be here. And then for this point here, it would be 2, 1, -1. So probably somewhere around here. So it would be this triangle here. So work out the area of this triangle. Okay, so press pause and have a go. Okay, so to do this, if you look at this, we've seen this before. If you have two vectors, if you mindlessly compute this, it will then give you the area of the parallelogram. But then we want our triangle, so we cut it in half. So we need to compute this value here. So going back, so looking at this, going back to this, we've got three vertices. We need to somehow extract the vectors. So we need to start from here, and then extract the vector here, and then extract the vector here. So we need to extract the vectors. This vector here and this vector here. We need to extract this vector here and then this vector here. When you mindlessly compute that thing, it will then give you the area of the parallelogram, and then you cut it in half. So the next step is to compute this vector here and this vector here. So let's start. Hang on. So bear with me. So we've got our three vertices. 1, 2, 3. We need to extract this vector here, and we need to extract this vector here. Well, this vector here would be you starting at B and then moving to C. You starting at B, moving to C. You starting at B, moving to C. So the vector will be, well, thinking of it in the x direction, I start at 1, and then I've got to move to 2. So that will mean I will move 1 in the x direction. Now looking at it in the y direction, I start at -1. I've got to somehow get to +1. So I'm going to have to move 2 across in the y direction, and then looking at it in the z direction, I start at 0, and then I've got to somehow get to -1. I've got to go down by 1, and then now we need to extract this vector here. So we start at B, and then we've got to move to A. So we start at B, and then we've got to move to A. So I start at 1, and I've got to somehow get to -1. So that would mean I have to move -2. I have to move 2 in the negative direction. So that would be this. So I start at B, and then I've got to move to A. So I start at -1, I've got to get to 1, I've got to move 2 in the positive direction. And then here I start at 0, and then I've got to somehow get to 2. So I've got to move 2 in the positive direction. So the vectors, so this vector here will be given by this vector, and then this vector here will be given by this. Now going back to here, bear with me. Going back to here, whenever you have one vector and another vector, if you compute the dot product, it will give you this vector here, and then the magnitude of this vector, will be the area of the parallelogram. So you just cut it in half. So the next step is for us to compute this value here. We need to compute the cross product. So we've done this before. So let's proceed. Hang on. So the dot product. The next step is we've got our two vectors. The next step is to mindlessly compute the cross product. So this is our vector here. So with the cross product, you always need these unit vectors, and then the first one, the second vector, and then mindlessly compute the cross product. So first one will be I, discard, and then just look at this. And then the second one will be J hat, discard, and then just look at this. And then for K, discard, just look at this. That will then be this. And then remember, it's just us following the procedure here to work out the cross product. So the next step is this is going to be a scalar. So this times this, and then take away this times this. So that would be take away -2. so that would be 6. And then it would be this times this, which would be 2. Take away this times this, which would be 2, so that would be 0. And then it would be this times this, take away this times this, so that would be plus 4. So that would, hang on, let me think. Let's start again. This times this would be 2, and then take away this. This should be a plus then. Bear with me. Is that right? Let me double check. Oops. Hang on. Let me double check. Where am I? Bear with me. So it would be. Hang on. Bear with me. So it would be this times this. That would be 2. Take away this times this. So that would be negative 4. This times this would be negative 4. So that would be positive 6. So I think this is going to be positive 6. So going down here, So and where was I? So the cross product would be this. But then to get the area of the parallelogram, we would need the magnitude of this. Because going right back to here, hang on. Going right back to here, whenever you have a vector and a vector, take the cross product, it will then give you this. This thing here represents this, and then the magnitude of this, hang on, bear with me, and then the magnitude of this represents the magnitude of this would represent the area of the parallelogram. So going back to here, bear with me. So we've got our cross product. So the magnitude of this would then represent the area of the parallelogram. So we need the magnitude of this. Magnitude would be this squared, and then this squared, and then square root it, and then that would then give you this. But then we don't want the area of the parallelogram. We need the area of the triangle. So halve it. So divided by 2. So the area of the triangle is given by this. Okay.